It all starts with a bunch of images going into Pinterest. The number of images is in the order of billions, being processed at a rate of 200 images per second. And for each image, they want to find out if that same image or a slight variation had been used before at Pinterest. At a large scale, solving this problem in near real time can be challenging to say the least. Pinterest's engineering team came up with a way to do this, but in batches. The first solution was a batch processing system that would take several hours to produce results, which is a problem when the consumers of that data need to act on it in real time, for example, detecting spammers and abusers trying to harm the platform. Given these requirements, the team set out to build a streaming pipeline that would detect similar images in near real time. There's so many moving pieces in this system, from Kafka, Apache Flink, RocksDB, and more. So how do they all relate? At a high level, the system flows as such. It starts with images that then turn into embeddings, which then get processed and go to Kafka, and from Kafka to a Flink workflow. The outputs of this pipeline then go to downstream consumers such as Pinterest Feature Store Galaxy, or custom graph storage systems such as Zen. Diving into the details of how they did all this is fairly complex, but let's take a quick look before we head out. The pipeline starts by taking the data encoded as numbers and reduces the size to something more manageable using an algorithmic technique called locality-sensitive hashing, LSH for short. The data then gets bootstrapped by querying Manas, Pinterest's custom search engine, to identify a set of potential candidates. This is known as the candidate generation stage. From there, they then score the candidates generated from the candidate generation stage using a TensorFlow model. This is known as the candidate selection stage. If during the selection stage a similar image is detected, Pinterest then goes ahead and identifies the cluster where it is stored and updates that data in storage. And that's it. Now, Pinterest's engineering team learned a lot from building this system and had a few pieces of advice for engineers interested in building similar systems. 1. Set up automated alerting and build observability into your system as much as possible, especially on upstream consumers. 2. Store the data in a unified way so that you can do things like backfill to a specific point in time and reprocess data. And if possible, unify your batch and streaming systems into one. 3. Add troubleshooting guides for on-call engineers and document the data as much as possible. 4. Take an iterative approach that starts manual but moves towards a fully automated system with CI/CD. And 5. Plan ahead for the many issues that come up when joining historical data to the latest values in real time. Memory issues, data freshness issues, training serving skew, data drift, and more. And that's all for this system design review. Thanks everyone.